Morning, everybody. BigStew here. Hope you're doing well. I know I'm still a little bit sleepy because here it is Monday morning and it's time to start a new online learning week. Last week, we introduced balanced forces, unbalanced forces, and net forces. So let's take a quick moment and recap. Balanced forces. This is where the forces acting on an object are equal. And either the object does not move because it was already staying still, or if it was in motion, the motion stays the same because nothing has made it change. The forces are equal. Then we've got unbalanced forces. The numbers for unbalanced forces are not the same. So the force is stronger in one area than in the other. Use the force. The force is strong in this one. This will either change the motion of the object by making it move to start off, or the motion that it already had will change. It'll either go faster, it'll go slower, or it'll come to a stop. And then we've got net force, which is the total amount of force acting on the object. You either add them all up if they're going in the same direction, or you subtract if they're moving in the opposite direction. Use an unbalanced force here to move this cat because she could be right in the middle of everything. Okay, so we went over these things last week. I thought this week we could do some practice. I have a prop. One thing I love about science props, you know what they are because there's always a name on there that tells you exactly what it is. This is no different. We have our box of science. You can tell it's a box because it has a label that says box. It's pretty simple. All right, so you notice that we have arrows that are pushing two different directions on our box, right? These will be our unbalanced forces. So let's say that the arrow that is pushing to this direction, I've got to practice with my prop, is pushing with a force of 55 newtons. And this one is pushing with a force of 20 newtons. Well, we know we have to subtract because the forces are pushing in an opposite direction. So for the problem, we have 55 minus 20. So let's put it up on our science practice board here. Got 55 newtons minus 20 newtons. And if we do the math, that leaves us with a net force of 35 newtons. All right. One thing to remember when you set up your subtraction problem, and sometimes I do this too, make sure your numbers line up so that it's easy to subtract. If you have your numbers all scooted over and they don't line up, it's easy to make a math boo-boo, and then you come out with the wrong answer and you think, well, I know how to do this. Just line up your numbers. If you need to, take a sheet of lined paper and make sure your number and turn it sideways. That's what my math teacher taught me when I was little. Turn your paper sideways, and then that way you can make sure that your ones column lines up and your tens column lines up. Simple little trick. It helped me because math was not my best subject. All right, let's erase this. Let's try another problem with our box of science. So let's pull these numbers off. And let's try this one. How about 25 newtons in one direction and 13 newtons in another direction. All right. It's hard to tell in a video which ones you can see as left and right. So we're going to say that this video is pointing to the right. This video, I need more sleep. This arrow is pointing to the right. This arrow is pointing to the left. Well, from my perspective, this is pointing to the right. But from the mirror image, this looks like it's pointed to the left for you, so just go with that. Okay, so 25 minus 13. Well, let's set it up on our board here. You got 25 newtons minus 13 newtons leaves you how much? Well, calculate it out. And if you need to, use a calculator. There is no shame in that, right? Lots of folks use calculators every day, right? Use the calculator so you can get the right answer. You come up with 12 newtons, all right? What if, instead of left to right, the arrows on our box here, we're going up and down. Let's say that instead of the box being pushed, it was being lifted. We're going to turn our box O signs this direction. Let's say that it was being pulled upwards with a force of 55 newtons, and gravity was pulling down on it with a force of 39 newtons. Let me back up so that you can see our box better. Well, which direction will the box move? Which force is greater? Well, we notice that 55 is a bigger number than 39. So we know the box is going to move up, but with how much force? Let's subtract it out. So we have 55 newtons up minus 39 newtons down. If we subtract this out, oh, and this is a wacky math problem because you got to change things around. So 15 minus 9 is 6. 1 minus 3 is 1. So we've got 16 newtons, and we said up was the greater force, so this box will be lifted 16 newtons up. You can do any practice that you want with the arrows. All you have to do is change the numbers. All I did this morning was I pulled up some sticky notes and wrote different numbers on them. And you can mix and match any way you want. Just remember, check your subtraction. Make sure your numbers line up in the ones and tens column to make it easy for you. And remember, the object always moves in the direction of the greater force. So if the bigger number is to the left, the object's going to go to the left. If the bigger number is to the right, the object's going to go to the right. If the bigger number is up, the object's going to be lifted up. And in the case of people who get into areas where gravity seems a little strong, if you drop the object, the greater force is going to be down. All right. Have a good one, and we'll see you again tomorrow.